Okay, so how's it going, everybody? Um, this video is going to do focus on some economic aspects of climate change. I'm just going to set some of the background here for later discussions. Just some very basic stuff that from past experience has been confusing enough. So, you know, hopefully this will make sense. And if not, there's lots of videos online you can Google. So the International Panel on Climate Change has a report that says that we are expecting basically everything I've been talking about in the past couple of weeks, right? So hotter days, fewer colder days, more extreme weather, droughts, that kind of stuff. When you think about all of these effects, they're going to have, science says that they're going to have some disproportionate impact on different parts of the country and the planet. So in the United States, it's particularly going to hit warm areas and low-lying areas tough. So Florida and Texas are in dire straits, Arizona, Las Vegas, a lot of other places. And some people would think that the way of thinking about this is purely to pay attention to the science and maybe the politics. And we've talked about the science, and we will talk about politics shortly. But there's also tools from the field of economics that might be helpful for us to consider. Namely, because climate change is going to be, or is a phenomenon that's global in nature, long-term, uncertain, and irreversible. And the reason all of these matter is if it was not global in nature, you could just study it somewhere else. If it was not long-term, you could study it shortly. If there was certainty, we wouldn't have so much worry. And if it was reversible, we could go back if there were problems. So it's important to study it as much as possible. And some of the tools developed by the field of economics might be helpful for us. Economists spend a lot of time thinking about risk and thinking about value. What they mean by value tends to be money. You might think that other things are valuable, right? So if I offer you 50 bucks to bring me your grandmother's liver, you might not think that that is worth the $50, despite the fact that it's more than $0, and you can't find other ways of monetizing your grandmother's liver. So there's some simplifying assumptions. Economists will talk about things where we all agree and accept the same values. And that is an assumption that I'm not even sure makes sense in economics, but almost certainly doesn't make sense in a global long-term scenario that is climate change. So economists study risk, and they think about it in terms of value, and of course, don't confuse ethical values with financial values or with other kinds of value. But nevertheless, these tools, we could use some of the tools from this toolbox. I always like to start off with a little bit of history, and one of the founders of capitalism that a lot of people avert to is Adam Smith, who at the same year that the Declaration of Independence was signed, publishes this book, The Wealth of Nations, in which he develops this metaphor of the invisible hand. A lot of people really like this metaphor. It basically argues that if a person is only trying to better themselves, by, say, milking a cow and taking that milk to the market and trying to make money from it, well, the fact that they're going to your market and not somebody else's market, and that the people that want milk get to buy it from this person, that's beneficial to you and to your entire community. So you are selling milk in the market, and you think that you are only trying to help yourself, but the fact that you're exchanging goods and services with people nearby and using the money that you get from them to buy their goods and services, that just makes the world go around and everybody is better off because of it. The timeline here is important. Adam Smith is writing this in the 1700s, about 30 years after the beginning of the Industrial Revolution in the United Kingdom, as you'll remember from your core humanities class. All of his examples, the way he's thinking about this is purely agrarian. A lot of people thought that, even Thomas Jefferson, for example, at the same time thought that the future of the United States was going to be agrarian. We would all be farmers. Very few of us are actually farmers. So Adam Smith's capitalism, as you would discuss in other classes, had unintended consequences in industrial revolution times. And I think now, given the information revolution, there's lots of other things to particularly make the picture more complex with respect to Adam Smith's thoughts. So again, I'm just trying to emphasize how these tools are helpful, but you should not accept them fully uncritically. Economists are making inferences about the future and about how people actually think about reality, and it's not just that they could be wrong, it's that we know that they very often are wrong. The question is, how much does that incorrectness matter? And is there anything else we can gain from those tools? One particular tool that I want to talk about is the tool of game theory. So game theory is the study of strategic interactions. Economists use it, evolutionary biologists use it, mathematicians use it, I guess board game developers use it. The basic idea of game theory is to assess how agents would interact in particular scenarios. And so a lot of these scenarios are really contrived. Here, I'm imagining you're crossing the border. This is one of the most famous games in game theory, the prisoner's dilemma. Let's say you and a friend of yours are coming over from spring break in Mexico, and you get arrested. And the Border Patrol tells you that they're pretty sure that you are responsible for killing somebody in Mexico or in the United States. They think that either you or your friend did it. It doesn't truly matter whether you're innocent or not. It might actually matter for your own psychology and what your decision would be. But for the purposes of game theory, the thing that matters is what is the most strategically beneficial action. So one way of simplifying this is to say, what would make you the happiest? So let's say you're trying to decide what to do. They've separated you and your friend, and they're offering each of you the same idea or the same deal to turn on each other. You can choose to ignore them and cooperate with your friend. And in this scenario, we're imagining that if you cooperate with your friend and they cooperate with you, you'll be pretty happy, they'll be pretty happy, because let's say the deal that they're offering you is that you get a 1 year in prison as opposed to the 10 that they're threatening to throw you in jail for. So this makes you both pretty happy. If you both turn on each other, on the other hand, they'll take off 5 years from your sentence for confessing, but you both go to jail for 5 years. And so you're pretty angry. On the other hand, suppose you give different responses, like you decide to be a good person and not turn on your friend, not accuse them of murder, but they um, they decide that they really, really just want to survive, um, want to go off scot-free, and so they turn on you. In this particular scenario, they've just accepted the deal that the police offered, and you are now going to jail for 10 years. So they're really, really happy because they get to go off scot-free. Same thing in the reverse. You turn on them, they trusted you, you're really, really happy, you get to go scot-free. It's important that you are happy here, right? Like your own personal psychology has to be accounted in these feelings. So this is the prisoner's dilemma. The prisoner's dilemma is this exact situation, and it leads to some interesting consequences. So assume you have to make a decision. You can be in the blue scenario because they secretly, they've already decided to cooperate with you, to not turn you in which case you have to decide between 1 year in prison for yourself or 0 years in prison. One of those options makes you happy, the other one makes you very happy. And you're deciding for yourself. You don't care about how happy they are. In this scenario, it seems like the best option for you is to defect, to accuse them of murder. Now let's imagine we're in the green world, and unbeknownst to you, they have accused you of the murder, they've defected on you. In that case, your option is between defecting, choosing to cooperate, and thus going to jail for 10 years, or also turning on them and getting at least 5 years off your sentence. So in this case, 5 years in prison is better than 10 years, a little angry is better than a lot angry, and you choose to defect again. The particular setup of this game in the prisoner's dilemma is this weird inequality where everybody prefers outcome C. Here you get to, in the example that I gave, was a super smiley face or going off scot-free. Second best option is if you both cooperate. Third best option is if you both turn on each other. And the final option is if they turn on you and you choose to cooperate. So as long as this inequality exists in this particular ratio, you have what game theorists and economists call a prisoner's dilemma. Okay, all of this sounds technical and you're probably wondering why you should care. It matters because we're going to generalize this shortly into the lessons from this, and then we're going to use those lessons to apply not just to two people in a really, really artificial scenario, but to climate change in general and how we deal with it, and why it's so hard to deal with climate change, why it's almost like the perfectly engineered problem. So we're in this case, right, prisoner's dilemma. I need to introduce two terms to try to make sense of what just happened to us. The first is Pareto optimum. And Pareto optimum is a situation in which no outcome is as good for every player. So both you and your friend who've gotten arrested, you pick a certain set of circumstances of how you behave toward each other. Pareto optimum is where everybody is happy where they are, and if anybody tried to change their actions, somebody would be less happy. So you look at the both of you cooperate scenario and you think, hey, this counts as Pareto optimum because any other of the possibilities would make at least one of us sadder, right? Now let's look at you turning on them, getting to go off scot-free. Well, you prefer that than if you both cooperated, right? 0 years is better than 1 year in prison. And you, in fact, really prefer that to any other circumstance. So that is a Pareto optimum as well, because that is your top choice. And that means that their top choice is also a Pareto optimum. So these three squares so far are all Pareto optimum. You end up in these circumstances, and there's at least one person that doesn't want to switch from it, doesn't want to change their action. The last square, that one's different, right? Here, and I realize that I have one arrow too many here on both sides. The Pareto optimum, this final square, every single person would prefer to be somewhere else. And because every other square is better for both of them, or at least one of them, this one is not Pareto optimum. So, can you see the screen? You can see the screen. There we go, sorry. So this last square is not Pareto optimum. Okay. It's good to know. That's one set of circumstances. There's another term. This is Nash equilibrium. If you've ever seen the movie A Beautiful Mind, it's about the story of the guy that came up with this, who was schizophrenic, nevertheless a true mathematics genius. Pareto optimum, Nash equilibrium is given full knowledge whether there's a scenario where people would not change their actions. I already kind of described this earlier. I said, let's lock down their options and you only pay attention to whether you'd prefer one alternative over another. So if you lock their actions, the bottom right smiley faces, you prefer to defect in both cases. We've already gone over this. Same for them, which means there is only one square where if everybody knew everything, that is where they would end up. So imagine, I mean, another way of thinking about Nash equilibrium is somebody tells you, hey, you have to make this decision right now, whether to turn on them or not. Psst, by the way, this is what they decided to do, and they slip their decision to you. In that case, Nash equilibrium will mean that both people will end up choosing this defect option. Does that make sense? Okay. The important point here is that Pareto optimum is not Nash equilibrium in this particular game. There are other games, and in fact, the test will have a different game. So try to use this kind of reasoning to think about whether Nash equilibrium or Pareto optimum makes sense of any particular square. The only square that is not optimal, that is the only square that makes everybody worse off than at least some other alternative, is the one that everybody ends up choosing if they knew everything. That's what's so weird about this particular setup. It's like we were contrived to fail. You were specifically put in a circumstance where all of the incentives are to make everybody less happy. So in the next video, we're going to generalize this to a broader community rather than two individual people playing. All right, so this video was about why economic issues matter in respect to climate change. Namely, the economists are used to thinking about the future, about risks, about values. They have certain tools. It's important not to fetishize economists or economics. Um, there are lots of simplifying assumptions that we actually know are false. Nevertheless, their tools are helpful in understanding a lot of things about climate change and really about any major decision of this sort.